So we have problem statement example 1.8. I'm going through it. An electron falls through a distance of 1.5 centimeter in a uniform electric field of magnitude 2 into 10 to the power 4 Newton per Coulomb. Okay, so this distance is 1.5 centimeter. 1.5 centimeter. All right. And what is electric field? Magnitude of electric field? 2 into 10 to the power 4 Newton per Coulomb. So as we know, the direction of electric field would be from positive to negative side. We have studied this part. And if the charge particle is negative, then the direction would be from negative to positive side. So these are the two cases. In first case, the charge particle is electron, and in second case, charge particle is proton. All right. As we know, electric force experienced by the charge in an electric field is equivalent to QE. And if the mass of that charged particle is m, then acceleration F is equal to ma would be equivalent to QE. Hence we can say A is equal to QE upon m. This is the case of, in case of electron, it would be AE, and in case of protons, MP. If we compare these two equations, we can see that mass is in denominator. So, and the mass of electron is 9.1 into 10 to the power minus 31 kg. And mass of proton is 1.67 into 10 to the power minus 27 kg. Hence, acceleration of electron would be greater than acceleration of proton because its mass is lesser than the proton. Anyways, we need to calculate these two details. So value of Q is 1.6 into 10 to the power minus 19 Coulomb. E is equal to, it has been given, 2 into 10 to the power 4 Newton per Coulomb. Yeah, I have already mentioned over here. ME 9.1 into 10 to the power minus 31 kg. MP 1.67 or 1. That we need to see what is the mass of the proton. 1.67, yes, into 10 to the power minus 27. Cool. All right, but in this question, what has been asked? The time of fall in each case. So how much time is it taking from this point to this? So in order to reach from this point to this point, how much time it is going to take? So as we can see, the value of acceleration is constant over here for electrons and for protons respectively. Hence, we can apply kinematic equation. So S is equal to ut plus half at square. U, the value of u is 0, half a t square. T square is equal to 2s upon a. So I want to erase this part. Can I? As we have understood this problem statement, so we can erase it. So the value of t would be under root 2s upon a, and in case of electron, 2s upon qe upon me. 2s me 2s me upon qe. So this is the expression we have got. Similarly, we would get the expression for proton. And what would be the expression? 2s mp divided by qe, right? So this way we can do the calculation and we would get the answer. So I'm sharing those details with you. So in case of electron, it comes out to be 2.9 into 10 to the power minus 9 second. And in case of proton, if you do the calculation part, it comes out to be 1.3 into 10 to the power minus 7 second. Similarly, we can do the calculation for acceleration of electron as well as proton. It is pretty simple. All values are known to us, q, e and me. You just do the calculation, and if you do the calculation part, then what you will get, for case of proton, the acceleration would be 1.9 into 10 to the power 12 meter per second square. So acceleration would be from this point to this point. In order to reach to this point in this path, its acceleration of particle electron, no, acceleration of proton would be 1.9 into 10 to the power 12. So if you do the calculation, you would get this figure. So this was all about problem statement 1.8. Okay, I hope the solution was clear to you. So thank you.